now that you've seen and worked with ionic bonding, it's time to look at the other type that you hopefully remember from grade 10 called covalent bonding. This involves the sharing of electrons. So when is bonding covalent? Well, in order to do that, we used to just say that it was a metal and a non-metal, but now we're going to look at the electronegativity values. So when the electronegativity difference between the atoms is less than 1.7, we say that bonding is covalent. So we're going to look at F2. Alright, so in order to, I would attempt to draw this. I'd start by drawing the Lewis diagrams, so it's just showing the valence electrons of both of the fluorine atoms. I'm going to look at the electronegativity values. So I'm going to go to my table. I'm going to find that they're both 4.0. So even though each fluorine has a really high electronegativity value, when I subtract 4 from 4, I get 0, and that's just essentially neither fluorine wants to give up its electrons to the other. So there has to be another way for them to stabilize. Alright, so what you would have done last year, you would have probably had this drawing and circled the single electrons. You would say that those electrons were shared between the two fluorines, and that we were going to call that a covalent bond. Common practice is to replace the circle with a line. Let's look at forming H2. So H2, you can see hydrogen atoms. The atoms come together, they get closer, they form what we call H2, the hydrogen molecule. So I'll just draw some of this. So if I draw two hydrogen atoms, I can say each has an electron in a 1s orbital. The atoms will eventually move close enough together that the orbitals of the adjacent hydrogens will overlap with one another, thus allowing the two electrons to be shared between the two atoms. Right? We say this is the formation of a covalent bond, right? And the two electrons are shared between the two atoms, thus completing each other's valence shell. Alright, we could actually redraw this as a straight line between the two H's, as shown on the animation just before this. Alright, we'll look at how to represent covalent molecules in an upcoming video.